Oh, no. Oh my God, how did I find this? I can't understand what it is. Yeah.
That's good.
All right, so how much do you guys remember about partial fractions?
No.
So if we were asked to integrate 1 over the product of x minus 2 and x minus 5, it would be easier if we could split those into two separate fractions, which is one of the whole reasons why you learned about partial fractions in pre-calculus. Yes, you need to know that. So to separate partial fractions, we create two separate fractions, one with a numerator of a and a numerator of b. Okay. So the idea here is we are going to multiply both sides by the common denominator. Okay. So that means if I multiply both sides by x minus 2 and x minus 5, x minus 2 and x minus 5, we would get, even this, x minus 2 and x minus 5. So we would get 1 is equal to a times x minus 5 plus b times x minus 2. Now, when you went over this, I'm assuming you went over this when you were talking about matrices, and you would set up the matrix where you had, let's say, the variable matrix, because if you multiply this here, don't write down what I'm about to write down, so I want to erase this because there's a shortcut for this. Okay, I'll show you the shortcut. So what you probably learned was that you had ax plus bx, well, there is no x on my other side, so that should equal 0. And you had negative 5a minus 2b should equal 1, because that's your constant. And then you have your matrix, your 2 by 2 matrix there, and you can solve for a and b that way. Yeah, don't do that. There's a shortcut. Okay. What are the zeros? Yeah. So if I plug in 5, all right, if I plug in 5, x is equal to 5, right? That means that what? I have 1 is equal to what? 3b. 3b, right? If I plug in 5, this would give me 0 times a, which would be 0, plus 5 times minus 2 is 3, 3 times b is 3b. So that means that b equals 1/3. All right, if I plug in the other 0, which is 2, x equals 2, that would give me 2 minus 5 is -3, so 1 equals negative 3a, which means b equal, or sorry, a equals negative 1/3.
So if the numerator on the original function was 2 instead of 1, would we set it all equal?
Yep. And that's what we're going to do. Yeah. So we set it equal to whatever's the numerator on the other side. So that means that I can separate this integral. So what we do, we can separate this integral from 1 over x minus 2 x minus 5 into the integral of negative 1/3 over x minus 2 dx plus the integral of 1/3 x minus 5 dx. Now, we can also bring out the 1/3, so we can write this as negative 1/3 integral of 1/x minus 2 dx plus 1/3 integral of 1/x minus 5 dx.
Could you write that? Like a 1/3 and then like this is intercourse.
Yeah. Because the idea is now we have two separate integrals that are honestly not so bad to solve.
Yes.
See if I remember what derivative gives you 1/x.
Ellen.
The log. So, the natural log of x minus 2, if I took the derivative of the natural log of x minus 2, what would you get? If I took the derivative of the natural log of 1x minus 2, you would get 1/x minus 2. Which means the antiderivative of 1/x minus 2 is the natural log of x minus 2.
Write that.
Since we know the derivative of the natural log of x minus 2 is equal to 1/x minus 2, that means the antiderivative of 1/x minus 2 is the natural log of x minus 2. So this becomes, and I'm running out of room, that's why I want to give myself, or you guys know what you're
Right.
So
So like I did 1/3.
So now 1/3 natural log of x minus 2 plus 1/3 natural log of minus 5. And then what can I not forget? Let's see, plus. Now, there is one issue here. One issue here. What can we not have inside of our natural log? We cannot have anything less than what? So how can I make sure that all my values, no matter what I plug in, it's not less than 0?
Oh, it's in the balance.
Absolute values. So these should be absolute values. That's all. So make sure you put absolute values on this. Yeah, because we can't have a negative inside a logarithm.
So parentheses and then absolute value inside of it.
You include parentheses. Absolute value actually are the type of. So let's try this. Right? What are my factors? What's the factor of my denominator here? Now, I don't know if you remember this, but you do. I don't think it's going to pop up on here. I think it is. I won't do that to you. But if you have any multiple terms, which means if I had like x squared in my denominator, or as one of my denominators, or I had x plus 1 squared, you would have to include both x plus 1 and x plus 1 squared as set. Okay. I don't know if you remember that, but you do have to do that. I don't think it's going to happen on today's homework. I don't even know if I can find homework for this. Okay. I will try.
No.
Other than just, if I can't, there's probably some stuff on the AV website.
I rather the website it doesn't help. It just confuses me more. It makes me sad. Because I never do it right, and then I just give up and don't try it again, and then I love the second half.
It's just multiple choice.
Yeah, but it makes me
still-
sad anyways.
All my scores do not show what I know.
Yeah, it's AP. It's,
So we're all gonna fail the AP test. No.
well, to pass, you make it better than 68.
And those were
That's 5.
a 68 5. Okay.
Yeah.
Alright, so your test in any way, I need in any way, instead of test, like, do you use AP questions for your tests?
The multiple choice questions, yeah,
Okay.
and the free response questions.
What's the bonus questions are AP questions? Okay.
So I tried to make sure I exposed you guys to AP questions.
Wait, what percentage is the free?
I don't know.
Let's look it up. Let's.
I'm gonna finish these notes first before doing it, because all we have is this page.
Oh,
Yeah. Tomorrow is, well, no, we have that long vision to do today too, so we do have long vision. Oh, yeah, long
A
vision.
third, wait.
A 38 to 49% roughly.
Yeah.
Three?
Yeah.
This says 2021 at 20.4% majority. What about? It said a 5 was a 38.3. Look, that's really bad. Maybe this was 38.3% pass, isn't it?
It's probably,
I think you're talking about like how many people
It says a 40 through 49 is a 4, and a 3 is a 13, and a 5 is a 50 through 69.
Yeah.
No good. That's my concern. Oh, wait. Hold on. 40 through 49 is a 3. I was reading it back.
okay.
40 through 49 is a 3. 50 through 69 is 4. And 70 and up.
Oh, sure. I remember 68, but it's.
Well, that's basically 68. Yeah. Okay, anyways, that's not.
So, if you multiply both sides by the common denominator, which is x and x plus 1, we would end up with x plus 2 is equal to a times x plus 1 plus b times x. Now, my zeros are x equals 0 and x equals -2.
Are we just making it?
Yeah.
Sorry, -1.
Yeah, negative.
-1.
I don't know.
I was wrong with that.
So you just find the roots.
Okay, so when you plug in, you just look at the numbers you're multiplying it to.
Well, it's just like this. Why does x
Because that's
plus
whoever
2
figured it out told us how to do it.
Is this the numerator?
When you put an exponent of 1, you get a 0 here.
So it's a denominator. It's well.
Yeah.
Integrals to this.
To make our separate fractions.
Just to make it easier. Just breaking down the integral, you know.
Zeros is not.
Fraction. And you just break it down to parts.
So that's a 0. 0 plus 2, which is 2, is equal to a times 1 plus b times 0 plus 0. So a is equal to 2. If x is -1, that will give me -1 plus 2, which is 1, is equal to a times 0 minus b, right? Yeah. So b would be -1. So now, again, I wrote all that way too, thinking I had room to write more stuff.
Will you just do this one and then erase all of it? And
So what does that say? A plus 0?
If you input x equals 0, you get 0 times b, which is 0. Just go with that.
It just looks like a 6.
So is the goal to turn everything on the inside into like 1 over something so we can make it?
Yes.
Oh.
We have 1 because we can factor out that numerator, or, yeah, and we do want 1. The reason why we want 1 over some functions is because we know the antiderivative of 1 over a function is the natural log of that function. So we're doing the integral of what, since a is 2 over x dx minus,
I did this type. I understand this.
so minus the integral of 1 over x plus 1 dx, which gives you 2 natural log of x minus natural log of x plus 1. Absolute values here, plus
Can you explain where the this was?
because the b was -1, so just put the negative outside.
out of there.
Yeah.
And
I just brought the negative out of the numerator.
yeah.
Because it was plus and negative, so you would still put plus and negative, which is minus.
No, I never understand.
You guys would try number 2 again?
Yes, please. Yeah. I can't do this as fast, so.
There they are. I found it on Delta Math. So let's look at the question.
I think.
So we have
Not that.
integral of a over x plus b over x plus 3.
Just 6 equals 3a, and
Yes.
5 equals 2.
That means that we have 3x plus 6 is equal to a times x plus 3 plus bx. So when x is equal to 0, we have 6 is equal to 3a, so a is 2. And x is equal to negative 3. We have negative 3 is equal to negative 3b, so b is 1.
So, yeah, I can't, I just, that's not fair.
So we get the integral of 2 over x dx plus the integral of 1 over x plus 3 dx, which gives you 2 natural log of the absolute value of x plus the natural log of the absolute value of x plus 3
Plus c.
plus c. That is a 3 here. Just trying to make me right, I swear. There it is. That's integration by partial fraction. Long division.
Yeah. This is perfect, actually.
What the next page says. Inverse trig operations include the square. So sometimes we're faced with situations whereby we're asked to integrate rational functions with higher degree in the numerator or the same degree in the numerator or denominator. When we see this type of problem, we must find a way to simplify the degrand. Yeah. For example, if we're asked to anti-differentiate x squared plus 1 over x, we can simply have to divide first. So we can rewrite this since we only have one term. The problem with the first one is we had 2 factors in the denominator. Okay, in order to separate those 2 factors out of the denominator, you have to use partial fractions. But we only have one term in the denominator. We can just divide each individual term by that one term. So we can divide each of these by x, so we get the integral of x squared over x dx plus the integral of 1 over x dx, which is the integral of x dx plus the integral of 1 over x dx. Which all I did was simplify. So first we separate the two numerators and divide each numerator by the denominator. X squared divided by x is just x, and then we can't do anything with x. What is the integral of x? What's the antiderivative of x? I have x squared plus the integral of 1 over x. Natural log of x, but again we have to have absolute value here. Equals c.
I like actually really overstimulated tonight. I'm actually really upset. Nobody's having anything. Is no one else getting overstimulated by vibrations?
I feel the vibrations. I don't know.
Vibration.
Yeah, I wouldn't be surprised. They're messing with the
Setting off bombs.
foundations. So
I just really
I was just wondering what's going to happen when I start knocking over this column.
I'm gonna use my side.
I'm telling you,
I'm getting
I'm
sensory overload.
One of the wrecking balls.
I did
It might recommend.
at the right end.
Actually, no, I
It
know. Like, it's like
It would be. So let's do that here. Right? We are going to do your now. Can we do synthetic division instead? Would you rather do synthetic division?
Maybe.
I prefer synthetic division.
Oh, it's not
Isn't that-
move the box and you go, okay.
So for synthetic division, what goes in the box? Do you remember?
First variable.
Set the equal to 1 so we get 1. Now, since we have x cubed, we need to have every term below that, which means we need a what?
This higher.
X squared,
Everyone.
we need an x and a constant. Now we have an x cubed that's 1. Do we have an x squared? So we put 0. We have an x, we don't have a constant, so we put 0.
Oh my god, I love this stuff. Let me see.
So bring it down 1. You do 1, which is 1, 1, which is 2, which is 2.
I thought x cubed plus x squared. I don't think I'm.
Wait, how'd you get one? Oh, you
I thought you were.
That's two then.
And then two's your
Oh,
remainder.
No, I mean, bring down the first one. Bring down the first one. Remember, everything below the bar gets multiplied by what's in the box, and you add that to the next number.
You brought down the cost.
Always bring down the first term, multiply that by what's in the box. That goes under the next number. So
You go.
bring down the 1, multiply that by what's in the box. 1 times 1 is 1. That goes under the next number. Add, get 1, multiply that by 1. Add, we get 2, multiply that by 1. Add, we get 2. So it means this can be rewritten as the integral of x squared plus x plus 2 plus 2 over x minus 1. Which we can integrate each of these separately. Right? What is the integral of x squared?
X to the third over 3.
1/3 x3. By the way, if you do write x a third over 3, that's perfectly fine. It doesn't matter if you write the fraction as a coefficient or just put the whole thing over 3. Makes no difference. All right, so the next one is what?
1
X squared plus 2x plus
2 x.
2 log of
Absolute value.
absolute value of x minus 1.
Oh. Let's see. No, that would be.
Don't forget plus c.
I like that.
So,
I feel like on the test I might do a problem wrong. Will you give us points if you remember the plus D? Just like 1 point. That'd be
Can
great.
you just put c
Or
on?
half.
Well,
point.
I could have like the entire equation wrong, but I have the C.
I mean, I give points for this work.
I would.
Yeah. I give points if you do
Are you gonna
work
take off
correctly,
work?
in the sense that if you start doing this in a correct way, but you make mistakes along the way, you still get partial credit for at least starting doing the work correctly. But if you just randomly throw stuff on there, it's like,
Just C.
Yeah.
I know it was C then.
I just sometimes should just.
so, practices. Now, the first one's not bad. The only thing we have to square that first. So we're gonna write that as the integral of what?
It's 2 to the 4th plus 2 x plus 1. Is that actually right?
Yeah.
Oh my god.
And
And then we divide. So we get the integral of x cubed plus 2x plus 1 over x dx, which is
1 plus x to the 4 plus
x squared
plus x squared plus plus
plus
oh.
yay.
Guys, I should have done some
When we school the calculus and said that.
It's a bit easier. Yes, sir. If we're doing anything, how can I make this next one easier?
Simplify the denominator.
Take out the negative 2.
Take out the -2, but it's in the denominator, so we're gonna take out what?
Negative
-1/2. So right, this is -1/2 integral of x minus 5 over x minus 1. Now, you can do synthetic division with this, or you can do normal division. There's only one term, in it, or one factor that matters, so no. So,
Wait, I'm on normal division. Would it be x plus 1?
no, it's negative.
Divide negative x.
So you can do synthetic division if you want. You can do long division if you want. I don't care which method you do this. Okay. Do you want to do the long division or synthetic? Which is fine.
Can you just do long division so I remember how many? No. Why do you take
So long division we have x minus 1 into x minus 5. And for long division, you always look at,
Oh. I never understood it.
so long, you always do the first term. Okay, so we always look at the first terms, x and x. What times x gives you x?
1.
1. So I'm going to take my answer here and I'm going to distribute through the divisor x minus 1. What does that give you?
Negative 6 or
Well, x minus 1. So, when we divide, do we add or subtract?
Oh, this is minus.
We subtract. Now, when I subtract, it's going to have all my signs.
they flip.
They
So
flip.
negative 4.
So that's gone. Now, the whole point is that first term goes away. If it doesn't go away, you did it wrong. Okay. Add down, we get negative 4. Now, that's my remainder. So I have 1 minus 4 over x minus 1. That's what I'm going to do the integral of.
So we have negative 1/2.
Negative 1/2 integral of 1 minus 4 over x minus 1 dx.
X minus 4 ln. The value. X minus 1 plus.
And then the 1 is boom. And x. Yeah. Guys, we.
Oh, and the one after.
Oh, and the 1 after that.
If you want to simplify this further, you can write it as negative 1/2
Yeah.
plus 2 natural log of x minus 1
Yeah, that's okay.
plus c. Notice the c did not get multiplied by negative 1/2.
Is it
Is
outside
it
the
the
first
first
one?
No, because it's a constant and doesn't matter. A constant will still remain a constant when you multiply by another constant.
But if you wrote like 2 or 1/2 c, is that?
I probably would have
wrong?
Dang.
But how is it wrong if there was a number there, you multiply it?
But we don't know what the number is.
C is
The c is just an ambiguous constant.
like you were thinking wrong.
Please.
This is
I do just spike really.
just to get paid probably. Just to be right.
Yeah.
It's on. Nice.
Wrong.
Why about art? I think about art.
It depends on what the month ends with.
Yeah,
Yeah. All the ones in it are like more, but other than that, like bolts.
I don't know why. I don't understand it.
Like I just keep going on. Like I have to open these more. It's just like the vibe.
Um,
I put all my cream.